welcome to episode 4. Today we're going to demo VSM. I'm going to call it VSM. I don't know if it's meant to be vasm, but I'm going to call it VSM for today. And this is only made possible by some awesomely grateful contributions by Frank, I'm going to say Willa. I'm not exactly, my German pronunciation's not great, so apologies if that's wrong. Phx from EAB gave me some awesome code that lets me get the line debug info out of an Amiga Hunk that's not compiled with Bevo's GCC. But we're going to start from a completely fresh, no settings, ENGINE9000 debugger setup, and we're going to go through how to get source level debugging from a VSM assembled program. So let's get into it. The first thing we're going to do is we're going to create a new UAE config. I'm just going to type in the name. Now I've got a pre-set up test example which doesn't have a UAE file, so I'm going to create one here. It's in the VSM folder, and I'm going to call it VSM.UAE. And we're going to point it at a floppy that I prepared earlier. And I'll show you what's on that floppy in a moment. And just the executable that we're going to debug, which is on the ADF, but also needs to be on the file system so that the debugger can access it and get the debug info out of it. We're going to select vasm, and it resets up our new Hunk toolchain. So this is all part of ENGINE9000, comes with it. We get the address line and obj dump that we need to get as much debug info as we can at the moment, but that's, you don't need anything else that'll build as part of ENGINE9000. And where is the source? So we're going to just point it at here now. Possibly you don't need this if your source build has full paths in the line debug, but we'll just set this up just in case. We're going to just set some core options at the moment. Load 9000, which is what we use to load our debugged files, needs start to, it shouldn't, but for the moment it does. I'll fix that at some point. And because we're loading from floppy, let's speed up our floppy, make that turbo. Okay, so let's see what happens. We'll save and reset. Oh, before we do that, let's just pause this and I'll tell you what's on this floppy. So this is the make file down here, or part of it. You can see we've got a program ADF9000. That's just a little program I wrote. It's in the ENGINE9000 source. It just creates make files. So it creates a new test floppy, creates a S directory, C directory, copies the startup sequence, which is this. So load 9000, break on entry, and VSM is the name of our test program. Here's the source to that up here. It's just pretty much a do nothing 68K assembler program. Yeah, copies that startup sequence and then copies those two binaries onto the floppy. So let's continue. So this should break when it reaches main. Let's fast forward, see what happens. And we're broken. So now we should have source level debugging, which you can see we do. So we've got the disassembly here, the source here. So we can do breakpoints in either window, but the line debug stuff, we can set a breakpoint in the main loop. We can look at variables by hovering. We can print variable names. So let's print. So we don't have full sort of Hunk level debugging, so we don't have access to variable like the symbol sizes and that sort of stuff yet. So for the time being, they're basically all variables like pointers. So if I print counter there, it's going to print the address. If I print the value at, so we're sort of C semantics here, we'll get the value, so 0. Let's see what happens. So here we go, we add 1 to the counter, currently 0, step over, it's 1. Similarly, we could go down and do that on the command line. Print counter, print out the value of counter. Print command does allow you to set a size. I don't think I put that in the help yet. You can specify the size in prints as well. if you want to just print a binaural word. So yeah, we can set breakpoints. So in this disassembly window, we also have access to symbols. So I could, for example, go to the hex loop, set a breakpoint there. You can see this, because we've scrolled in this window, this is locked. So I'll unlock that to show that we've had a breakpoint at that hex loop. Similarly, if we pick another symbol, let's say print string, let's say that I print the console down here, print string, get that address. We could, for example, go to an address in the assembly window and set a breakpoint. Or up here, print string, get rid of the hex loop breakpoint. So yeah, we can set breakpoints. Well, once again, we can set them by in the command console down here. So I could go break main loop down here as well, or I can set them by on the gutters here, or by setting in the disassembly window. So we've got quite a bit of options there for setting breakpoints. You can see also we can disable them here, toggle them all off and on, or set individual ones. Yeah, so yeah, we've got pretty much all the good action in the source window as we do in the C version, apart from the sort of local variable C, local variable stuff, and symbol sizes. But other than that, you know, we can do stack sort of based operations. So I can step out of this one. We're back in the main loop here. So if I just do this next, this is like a C next. If I just get rid of, let's get rid of all these breakpoints apart from the main loop. Let's clear them all, add this one back. So this is sort of stepping over all of these routines. So or I could step into one, step in, breakpoint, step out. So yeah, it seems pretty good so far. Obviously we'll improve it as we go. Yeah, that's probably all we've got for today. See you next time.